Hello everyone, my name is Lucia Salgueiro and I am TA1 of Group 4 and I'm going to talk about inferential statistics. So let's start with an example. Let's say we are going to run a trial to test a new intervention for losing weight in patients with type 2 diabetes. So our target population is all the people in the world with type 2 diabetes. We are going to take a subset of this population that will be our sample. So we are going to divide our sample into groups. One group is going to receive the new intervention and the other group the usual treatment for losing weight. And we are going to use descriptive statistics to characterize and summarize all the data of our sample. And then we are going to use the inferential statistics to apply a statistical test to this data to infer conclusions about our target population. So we are going to apply a statistical test to find out if there is a difference in the reduction of weight between these two groups, okay? So a statistical test determines the probability or p-value of a significant difference between groups, in this case, between these two groups, okay? So it departs from the initial assumption of what we call the null hypothesis, that is that there is no difference between these two groups, or in this case, that there is no difference between the reduction of weight between these two groups. That is the current knowledge. And what we want to prove is there is a difference between these two groups, between the reduction of weight between these two groups, and that is the alternative hypothesis and the new knowledge. So, if the p-value of our statistical test is small enough, then we can say that there is a significant difference between these two groups, and that difference is not by chance, but because of our intervention. And we are able to reject the null hypothesis and prove the alternative one. So our PICOT is the population type 2 diabetes patients, let's say a sample size of 400. The intervention, a new intervention for losing weight. The control, the usual treatment for losing weight. The outcome would be the improvement or reduction of weight after 6 months. So it is a difference between weight at 6 months and weight at baseline. And the time is the follow-up period that in this case will be 6 months. So our null hypothesis would be that there is no difference between the means of weight variation or reduction between these two groups, and the alternative hypothesis that there is a difference between the means of weight variation between these two groups. So how we conduct a statistical test properly for this case? Well, first we have to determine the variables. We have the dependent or the outcome variable, in this case weight, or reduction of weight or change in weight, and the independent or the intervention variable, which is in this case treatment, which is usual treatment or new intervention. Then we have to classify them. Weight is a continuous variable. It's a numerical value that can also have decimals. And the treatment is binary or categorical. There is just two options, the new treatment or the usual treatment. So with this information, knowing that the dependent variable is continuous, we can check for the assumptions for using parametric tests, which are t-test, ANOVA, and linear regression. So first, the distribution of our dependent variable that we may assume that is normal because of the central limit theorem that says that if our sample is large enough, then we could assume normality. And if it is normal, we can use parametric tests. So that assumption, we could match that assumption. Another assumption is data measurement. It has to be intervals or ratio scales. Another thing we have to accomplish is that our sample was taken from random sampling. And the last one is we have to check for homogeneity of variance between both groups, okay? So if we accomplish all of this, we can use parametric tests that are more robust and powerful than non-parametrics. So if we go to this chart, we can see that we have the dependent variable, which is weight, which is a continuous data with normal distribution. So we can focus on this column. And then we'll go to the independent variable which is treatment. And we can go to this row that is compared to groups, binary, which is our case. So we can match both in this, that is t-test, okay? So in this case, the best or the one, we could apply a lot of different tests, but just to begin, for you that are beginning to understand statistics, to select one, we may say that this is the path. We can choose for t-test and would be some simple, easy, robust, and powerful test to apply in this case. So I hope this has been useful for you. This is just a glimpse of inferential statistics. And okay, that's all. Thank you. Bye-bye.